Okay, I thank you for your kind words, Marie, and fantastic introduction to EGEC. It's great to have half of your work done for you already, so I don't need to explain who we are. It's also my focus is on the kind of the policy structure, the kind of architecture. So, kind of to give you some food for thought for the consultation that you've mentioned, but also how do we build out a much more mainstream conversation around geothermal within Ireland. Thomas is going to go through in a lot more kind of granularity on some of the financial aspects, but I really want to talk policy today. So I've kind of broken my presentation down into 3 points. The first one is to just a broader understanding of what the mainstream geothermal energy conversation is all about. Then I want to go into the regulatory architectural design questions that need to be posed by policymakers, and then just to give you some insights into how other countries have gone about the business of building out a geothermal energy system within their country. So I think it's first of all, just to remind ourselves, we're all very, very familiar with the concept of geothermal energy here, but it's important to recognise that it's just beyond the energy issues. Within Germany and France at the moment, there are plans afoot to extract lithium, which is an important additional benefit to geothermal energy in the context of the decarbonisation story that globally we're facing. The baseload electricity allows us to have much more grid balancing, grid stability, energy security, and of course, aside from lithium, we also have silicon in a few geothermal wells. So we are more than just an energy solution. We are, we have the luxury of being multiple. We provide multiple solutions to multiple problems, so that's very important. Now, one of our earlier projects, GeoDH, Geodistrict Heating, looked at the general scope for heating and cooling decarbonisation across the geography of Europe, and what we find is that one of the common myths that we come across is that actually geothermal energy is geographically constrained to a few regions, and what you find is that actually the world literally is our canvas, and if we're serious about getting the policy architecture right, then actually we can lead to rapid decarbonisation of heating and cooling, which is still 50% of our energy consumption within Europe, but also globally, and it's an area that's been sadly neglected. The other advantage of geothermal, and we're going to go through costs later on, but it's just worthwhile recognising that once we've built out a geothermal energy system, actually the operational costs mean that the total cost for consumers are actually much lower compared to gas. So this is a study that was conducted by ADEME, which is the French Environmental Energy Association. There's a link to this further within the report. And I'm going to come back to this slide because the case example I'm going to run through is France. So it's important to have France, within the background. As you're familiar, France is a nuclear and gas based energy system. And what we find here is that the cost for gas is substantially higher than the cost for geothermal, the levelized costs. So it's, geothermal, for all its upfront cost, is actually, over its lifespan, a very economic energy solution. It's also increasingly starting to get mainstream. So this is the CEO of E.ON, the big energy utility, the head of the Swedish office, and E.ON have just moved into geothermal. Many utilities across the globe now are seriously exploiting geothermal energy and busily trying to develop projects at city levels, partly because it provides a long-term abundant source of energy, and it doesn't have a lot of the kind of constraints that we have with other renewables. So what you're starting to see is the noise around geothermal is increasing rapidly. If you take just the example of district heating and cooling, this is from our current market report. Thomas is busily working on our new market report, which is coming out in a month or so's time. But you can see that there's already over 300 plants. We expect more than 500 plants to come, and hopefully we would like to see Northern Ireland feature on the chart here as well. So this is the work we have to do together. But the crucial thing is that the pipeline for geothermal is growing. The question for us is it's not growing enough, and that's a policy design issue rather than a technology one. So okay, let me move on to the regulatory architecture. And just to put this in context, we now have to decarbonise at a much faster rate than we've had to decarbonise before. This means that we've got to get the policy architecture right. And as I've mentioned, many roads are now leading towards geothermal. And if we get the policy design right, then actually what we'll find is that there's less reliance on the public purse and much more on private leverage, which means that if we get the policy architecture right, we have a geothermal decade. If we get it wrong, we have a lost decade. I mean, this is the words of Michael Liebrecht, one of the key energy modelers. Now, it's important to understand the full geothermal energy system. There are multiple stages. There's the first stage, which is the kind of the design, construction, exploration, drilling, associated with the actual geothermal system itself. And then there's an additional aspect when it comes to the context of heating and cooling to build out the infrastructure, or if we're looking purely at power, again, to ensure that there's grid connectivity or a customer base. So there are two aspects to geothermal energy. It's important to understand that they have two different regulatory drivers, one way or another. When it comes to kind of classic policy design, of course, we're looking at a supply push and a demand pull in order to drive the market. Within a supply push, obviously, the key focus has got to be on de-risking the drilling phase, the first phase, and also the second phase around any associated infrastructure. Underpinning all of this is the approach to licensing and permitting. Now, this is a sensitive issue. It is for all technologies, but it's important that we don't get lost in the weeds when it comes to licensing and permitting, because that does have a significant there's a significant impact in terms of the overall cost shape for a geothermal energy project. On the other side, it's one thing building out the supply, but we also need to ensure that there's a sufficient demand. And that's where policy is really needed to drive the market for renewable heating and cooling and electricity. In some cases, we have across many countries in Europe have unilaterally taken on heat decarbonisation targets. Austria is a classic example. Their new decarbonisation pathways effectively shifting from a reliance on gas as a bridging fuel to purely going straight into renewables. So for them, geothermal, electricity, heating and cooling are central part of their decarbonisation pathway. And it's good to look at their thinking at the moment on how they're going to approach this. Some countries have gone down the road of banning appliances for heating and cooling. We expect to see more and more countries moving in this direction very soon. This is just for heating and cooling. Of course, when it comes to coal plants, many countries are shifting out of coal because the economics of coal have just collapsed. What we're starting to see now, however, is a shift from coal to gas, and that's one of the policy challenges that we have to focus on. And part of that solution, the toolbox there is a tax on some form of fossil. So the UK was part of the European emissions trading system, but it's had a long history, the climate change levy, of applying taxes on fossil-based consumption. And I think these are the kind of the broad pillars around which we need to think of the regulatory framework. So let's talk about market design. And I think the best thing here to do is just to take a case example, because it's learning how other countries have approached issues that we can get an understanding of the system and the approach that's needed. So we take the example of France. Obviously, in the 70s, we had two big oil shocks. France decided very famously to invest in nuclear. What is really underreported is the fact that the other big bet they made was on geothermal. To address geothermal, they identified two key risks, the two risks that we had on one of the earliest slides, around the initial project exploration and drilling, and then the actual project development to the consumer phase. So they established two risk insurance funds. Thomas is going to go through these in a bit more detail, but I'm just giving you these as a flavour of the direction that we need to be looking at when we're designing policy. So there was a long-term guarantee fund and a short-term guarantee fund. The crucial thing about this is that they substantially brought down the cost for drilling and the cost for building out an infrastructure to then gradually build up demand. from a policy perspective, for every €1 that was invested in the long-term fund, in the short-term fund, €42 was returned through private leverage. So, you know, it's important to recognize this is cost effective. What we need to do is to de-risk the actual project development phase, and then the private sector will almost jump in, partly because of the long lifespan for a geothermal capacity. So for the short-term fund, again, for every €1 that the French government invested, €32 came from the private sector, and that's kind of really helped to build out the industry within France and the sector within France. Now, of those two funds, they were limited in time. We were looking at a time scale of about 15 years for some, and you can see that in I think they both came in 81 and 82, but the policy thinking was already being designed in the late 1970s. Excuse me. And what you see is a huge number of investments in just within the Parisian Basin for geothermal projects. So this really did drive the market in the short term. And what you then see is a big gap. And that big gap is the uncertainty because of the fact that there was a sunset clause put on those two funds. When a new fund was created, then all of a sudden the industry took back off again. So one of the key lessons when it comes to designing a system within Northern Ireland, we would recommend in any other country, is just to have no sunset clause on any form of a de-risking instrument, because there is a direct correlation between this and the speed at which the industry is built out. When it comes again to the Parisian Basin is one of the largest geothermal heating and cooling networks within Europe. I think maybe even globally, but I need to double check that one. There are a couple of issues that that we need to think about when it comes to again looking at the non-financial risks to project development. This is work that's actually come from our president, and his experiences of actually working on the Parisian basin as well as other geothermal projects. So the first one is to look at the listed graphic correlations. Very, very important to make sure that we have the best understanding of the deep geology that we're associated with, and then wherever possible to use the most sophisticated technology that's available. Now, one of the examples that we have in Germany is with the city of Munich. The city of Munich have decided to effectively decarbonize their entire heating and cooling system by shifting over to geothermal district heating systems. The reason why they've been able to, and they're looking at bringing on 500,000 people within the next couple of years. So this is a big project. The crucial thing there is that they've been able to really target their investments in their infrastructure because they use the 3D modeling that's used by the oil and gas industry. So there's a second lesson here as well, that we have a lot of assets and a lot of expertise within the oil and gas industry which need to have a new home to find. And if you can redeploy them within the geothermal heating, cooling and electricity space, then actually it allows for much better project development. That's a key lesson, and certainly something that the UK's long history of oil and gas and fossil extraction, this is a key market for them, for those technologies to be applied, sorry. Then we have again, other skills which are wrapped up at the moment within the oil and gas extraction industry, but are very, very pertinent to geothermal, is the well architecture and the different types of directional drilling. This is an expertise which is absolutely essential to not just bringing down the cost, but actually better exploiting existing wells. And it's something that we can't write into policy, but there needs to be some form of an incentivization to encourage people who are drilling for a barrel of oil, which once extrapolated is $70 compared to hot water, which sells at 10 euro cents. So there's a big difference financially, but helping to reposition and transition that expertise and that skill and that assets over to geothermal energy is one of the challenges that we need to face. We can't mandate it, but certainly we can find ways to look at tax incentives and other structures to help bring down the cost and encourage the transition there. Obviously, selecting the right drilling site is essential, as well as innovations around well architectures. There are multiple examples of this across Europe at the moment, globally as well. And again, a lot of this expertise is locked into the oil and gas industry. So the quicker we can help them transition, the better it becomes for the entire industry. As you can see, there's a kind of unique aspects to the Parisian basin that we see here, but irrespective of the geology, it's really the success in France was down to how well they organized all of the machinery of legislation and financing to best exploit it. So the reason I picked the Paris Basin is from the little I've seen of the geological mapping within Northern Ireland. You are pretty much sitting on an equivalent resource, and it's not about mapping the resource, it's about how do we design and incentivize people to exploit better the resources that we have within us. So what you find here is actually, as far as I can see, it's not too dissimilar of geography in terms of the depth of penetration that's needed for drilling. So let's look at the two different markets. So obviously there's a market for power, there's also a market for heating and cooling. The market for power is very, very important. Electricity, we're going to increasingly electrify, but at the same time, heating and cooling is where the hearts and minds of the energy transition rest. And it's important that we equally focus upon those. So again, one of the advantages of geothermal is its very, very long lifespan. So half the French district heating systems were from the original drilling that was done in the 1980s. This is a feature that we have that very few other sectors do. However, there are issues in terms of how do you build out and extend the existing capacity, and actually how do you then bring down the cost of building out more infrastructure extensions. So what are the kind of the challenges that we face? I'm conscious I'm running out of time, so I'm going to speed up a little bit here. There's a model that's worth looking at, is the system that was deployed in Barcelona, where effectively you are building on a modular basis, extending your district heating system. Again, it makes the economics much more viable. It's much of a lower risk project approach, and it's certainly something that helps expand the overall economics of a project, but the viability of different wells as well. Another example is to, again, look at the targets that we have kind of within policy at the moment to drive the decarbonisation of existing district heating and cooling systems. Now, I didn't have a chance to look and see if this is an issue within Northern Ireland, but across at the moment, there's a big policy conversation around decarbonising existing district heating and cooling systems where the infrastructure is already built. So it's just a case of literally plugging into those existing systems. Then there's an issue around carbon pricing. This is ultimately going to be a big challenge for everybody. We have a carbon price on electricity, but there's no carbon price on heat. The moment there's a carbon price applied to heat, again, the economics for geothermal switch quite substantially very quickly. But more importantly, if there's a subsidy for a fossil fuel, then that puts geothermal projects at a disadvantage. So whilst it's politically hard to remove fossil fuels subsidies, we should at least be getting the same level of subsidy. That same level of subsidy, that bang for buck, and the ability to bring in the private capital, certainly from pension funds, again, makes geothermal that much more viable. Bear in mind that it's hard for geothermal to get into the market, but when it gets into the market, it's by far a safe bet, and that's something that's very important. Now, we've just had taxonomy, so the kind of the definition of what's a safe investment and what isn't, and that's going to help shape private sector thinking. And as geothermal is largely viewed as infrastructure, then actually that makes it a safer bet for private capital to come in. We just have to make the connection within the minds of financiers on what's needed here. And then the last, building out the supply and the demand is important, but also bringing down the cost of the actual supply itself. This is the role of risk insurance. As I've mentioned, this was a significant feature within Germany, France, many other countries in terms of the growth of their sectors. we're going to go through this in a lot more detail through Thomas, but you know, the key thing is that there are different types of risk insurance that's needed, but what we need to do is just to have a risk insurance system, and it needs to have a long-term visibility. Then there are different kind of financing models that are available in terms of, you know, how would you finance district heating in the Netherlands, sorry, in Denmark. It's an ownership based model. In France, you have a guaranteed consumption rate from municipal governments, which basically allows for the project to go ahead, and then you have time to build out, more and more customers coming on board. We have the European Investment Bank, the largest global bank, and this is again an opportunity to target, you know, to move beyond just the energy consumption sectors into agriculture and other spaces as well. So again, there's a lot of information here for you to digest, but you know, the key thing is that whatever framework needs to be established over a longer period of time. You can have innovative financial means, crowdfunding is one, but risk insurance in many ways is the crucial pillar. Without that, it's very difficult to build out your geothermal plans and to really exploit the capacity that you have to a full extent. And you can see this with, for example, some countries within Central and Eastern Europe who are sitting upon, you know, equally rich reservoirs of geothermal, of heat reservoirs and basins, but they haven't been able to exploit them to the extent that France and Germany have because of the lack of that risk insurance funding. So, you know, I've said this a million times and I keep on saying it a million times. If there's one recommendation to make, this is, you know, it's got to be, how do we design a risk insurance system that really does cover the full scale of the drilling aspects, and you know, and then you can look at other innovative things. You know, crowdfunding is important not because of the money that it brings in, but the awareness that it raises. And I think if we're talking about, you know, energy systems where you're going to have connectivity to a community, then you know, raising that mainstream awareness of the energy solution is a very, very important driver for you know, not just for the actual projects, but for the community overall. So, okay, so what have I done? I've gone through a few examples of how France has approached, you know, building out its geothermal energy regulatory architecture, and I basically stressed that there are two things that we need to focus on. We need to focus on bringing down the cost for drilling and construction, and then, you know, finding ways in which we can create demand. And though, if we can answer both those two questions in the design of Northern Ireland's energy strategy, then I think that's going to be the bedrock for a very, very rapid growth within the sector. So at that note, I will stop there and thank you all for an opportunity to talk to you. If you have any questions, you're welcome to come back to me, or maybe we can go to Thomas's talk and then take them all together.
To let some time for the discussion afterwards. Maybe very quickly, Sanjeev already presented this this overview of the European markets, but overall, what we can have in terms of key figures for geothermal in Europe is we have about more than two. I think it's actually now getting closer to 2.5 in the EU for gigawatts of geothermal district heating capacity. There are 130 geothermal power plants, which are typically baseload plants, so that's a very interesting feature. Although in the short term, that might not be the most relevant solution for Northern Ireland, but maybe in the longer term. And then there are more than 2 million geothermal heat pumps at the end of 2019, 2.1 million in 2020, which represent about almost 30 gigawatt of thermal capacity, so quite significant. And then at the end of 2019, beginning of 2020, we have had the first experimental extraction of geothermal lithium in Europe. So that's a new step. So mineral production for geothermal is one of the new frontier maybe for bringing this technology much closer to mainstream in the market, basically, providing a new stream of income. Now, looking at what forces shape the European geothermal market and which are especially relevant areas to look at for establishing a geothermal industry in Northern Ireland. Sanjeev mentioned most of these. It's typically policies are very important. I really want to insist upon the permitting framework, which and the quality of the regulatory framework to make sure all the environmental licensing, environmental permitting, etc., is all very clearly defined, and the ownership of the geothermal resource and the licenses to exploit them need also to be very, very clearly defined. That's essential to really have projects, especially private sector projects. That's a very, very important first step. Here, the GEOENVI project has a lot of very interesting recommendations. We had a series of webinars in the past few months, which explored these thematics, and we also had some deliverables, some reports, which go into further details about recommendations typically for environmental regulation of geothermal energy, etc. Now, the knowledge of resource, obviously hugely important, and here I know you're already quite far ahead in identifying what you could be deploying in terms of geothermal projects in Northern Ireland. Having the right financing scheme, and that's going to be the bulk of my presentation, is really crucial, obviously, especially if you want the private sector to come in. Then innovation, always a key measure. I just mentioned mineral extraction, very, very interesting innovation, but you also have a lot of different innovative innovation that, when translated to the geothermal industry, bring costs down and bring the industry into a new area. One very recent example, for instance, was in the Paris region. The NG used horizontal drilling for a geothermal district heating project, so technology that derives from the oil and gas industry, which was never before used for geothermal. And this really expands a new realm of possibilities in terms of capacity of projects, scalability, etc. So always very interesting. And then obviously planning and, as Sanjeev mentioned, availability of infrastructure is key, especially for geothermal district heating. But planning and having the right zoning laws as well is also very important for geothermal heat pumps. So this is quite important. Now, one thing to look at, especially when we look at financing geothermal projects, is to understand the cost structure of projects. So here you have a breakdown. I'm not going to go into too much detail, but what we have to notice is that a lot of the project is actually field development. So basically the underground work. So you have well, planning, etc., which is obtaining authorization, licensing, very important part of the project, which can actually create a lot of delays. So it might not be huge in terms of amount of money, but if the framework is not right, we have some examples of a geothermal project in Italy, which have been waiting for over 10 years for authorization, and that's very, very negative for developers. So certainty and clarity in permitting and licensing is very crucial. Exploration, obviously, is you need to understand your project. Here, some exploration can actually be done maybe in the form of national or regional campaigns for exploration. And then obviously the drilling is a huge component of any project development. It's 40 to 70% of a project cost, as Sanjeev mentioned, and that's really one of the main areas for cost reduction. And then you have all the surface equipment. That's for a geothermal heat plant, typically the heat exchanger, having the connection to the district heating grid, etc., which are still a significant investments. But once you are at this stage, typically your project has very little risk because you know all the parameters. But this, at least until you complete your exploration drilling, you have a lot of risk, and I'm going to come to that a bit later. No, this is another type of project. This is increasingly what we are seeing is a merger between geothermal heat pump project and traditional, let's say, geothermal district heating projects. So you don't necessarily always rely on the temperature of the water that you found. You might actually add a heat pump to your project to make it either fit your district heating requirements, or if you did not have, let's say, the perfect resource, you only found, I don't know, 30 degrees water instead of 60 or 70, then you could actually put a heat pump with very high efficiencies to have a project that actually delivers the needed energy to your community. So as you can see, the different costs between the two projects are not huge. Large-scale heat pumps for a 10-megawatt project typically is around 3-4 million. So it's only about 10% of a project cost. No, not 10%, 20%, sorry, of a project cost. It is significant, but it's not a huge barrier. And we see in the Paris Basin more and more projects are actually implementing this technology to be able to do more projects and scale up geothermal capacity. Now, last cost breakdown I wanted to go through, and here we actually have it's one example of a geothermal heat pump installation. You have many different types of geothermal heat pump installations. So they are not all going to be in the 60 to 80K range, but for a 50 kilowatt capacity geothermal heat pump, this is about the cost you could expect. So system design is a small part of it, but it's an important step to really optimize your system. More and more what we are seeing is the optimization of systems around heating and cooling, even in colder climates. So that's also an important thing to consider. Even in Northern Ireland, it allows you to recharge your borehole during the summer period, as short as it might be. We know they are also optimizing for cooling in Sweden and Finland. So it's really a growing trend. And for larger buildings, it's especially important because all large buildings are using some form of cooling for part of the year. And there again, drilling is a very large part of the cost of the system. And then the heat pump part is basically similar to an air heat pump. But here, with the drilling over the lifetime of your project, you actually gain a lot of life cycle costs, basically. But you need to have the right models to allow people to undertake this investment and to allow business to install this type of systems. But things to be considered as well. Geothermal is not a mature technology in terms of markets and therefore in terms of costs. So we can expect a lot of cost reductions in various markets. And for basically all technology segments. So in the case of Northern Ireland, or more generally Ireland, actually, it's still a very emerging technology, especially district heating, but even heat pumps are not entirely at full market maturity. So you can expect a lot of cost decrease, especially via the learning by doing. So really having a reduction of drilling costs as you have more competition in the drilling suppliers, as you have more projects available, as the geology is better understood. So knowledge of the resource for deep geothermal is really essential to bring down costs. Then obviously economies of scale are also important. In the case of geothermal heat pumps, the availability of trained professional and skilled professional is also important. So typically we are working in EGEC at the development of high quality European standards for training and certification of shallow geothermal developers. That's also an important step. And obviously enabling innovation to allow market maturity to progress. So Sanjeev already went through this slide, so I'm not going to go into much more details. This is another slide from the same study coming from France, which is a very interesting study comparing the cost of various renewable technologies. And you can see that geothermal heat pump here in this, I'm not actually sure whether you can see my mouse, but in the heat pump water to water here represent geothermal heat pumps are a very competitive renewable heating and cooling solution for households, basically. However, what we have seen in France is the market was extremely dynamic with sales about 20,000 units a year. And then there was one small change in the support framework, which all the students really destroyed the market, which fell at about 10% of what it was at only about 2,000 units per year today, although it's a very competitive solution. So having the right support and regulatory framework again is really important. Having predictability and stability for the industry is really essential. Now coming back to this topic of risk, this is a very basic representation of what is the issue with geothermal risk. So first you have to spend quite a lot of money. So this is this gray arrow. Before you actually decrease significantly the uncertainty, so the risk of your project. So you need to do your exploratory drilling to make sure first what is going to be the temperature that you can tap into, and what is going to be the flow rate of your project. So the amount of water you can extract, and therefore the size of the plant you can install, and the amount of money you could make from it. So this is obviously a huge issue. You have many technical ways to decrease the risk before you actually do an investment. So via exploration, better knowledge of the resource, etc. And you have some financial ways to decrease it as well by minimizing the risks that only one person has to carry the one time that a project is going to fail, because we typically have a 10% failure rate only, compared to oil and gas, which typically have, if I recall correctly, about 30 to 40% failure rate in the wells. But the one single oil project is so much more profitable that you can afford that. So ways to increase, well, to allow the market uptake is obviously to tie the right risk mitigation scheme to the right support schemes. So first, typically, we here you have some examples. So it's a little bit geared towards electricity, this graph, so not entirely relevant if you're more focusing on heat transition. But anyway, the main idea is still relevant to have in very early markets grant support to really support the uptake of the first projects, to have some examples of successful projects, acquire data on the geology, etc. This is what, for instance, is being done in Poland right now, with the government providing some grants for drilling the wells of several geothermal district heating throughout the country. This acts as a de-risking today because projects do not face much risk, and also as a de-risking tomorrow because all this information is going to be used as reference for future projects, which will be able to be more market exposed. Then you move towards, let's say, some more mainstream type of support schemes and some form of public or private risk mitigation, private risk insurance, sorry, or public-private typically. This could be feed-in tariffs for heat, which is something we have seen in the Netherlands, or some form of investment aid, which is the case in France. Then you can move towards support schemes that are exposing projects a little bit more to market forces. In the electricity sector, this is typically feed-in premiums, but you could have many other type of framework, for instance, tax rebates, as in the case in the US for geothermal power plants. And then finally, it's all about having the right business models. And this is obviously a little way down the road throughout Europe, but it is having, in the case of geothermal power plant, the ability to market the fact that they are baseload and flexible. In the case of, let's say, geothermal heat pumps, the ability to maybe market the flexibility provided by, for instance, storing heat in the borehole field, etc. So this is, let's say, emerging models, which we are not yet quite solved, to be honest. In the case of risk mitigation, especially, so Sanjeev already presented you this slide, but maybe to go into more details, there are many different ways to mitigate the risk of a geothermal project. So you can provide a grant to finance drilling. That's what Poland is doing right now. You could also have grants that you repay either only if your project is successful. So there are grants, but you might need to pay the amount of the subsidy you received if you had a successful project. So you are de-risked because in case you do not, your project does not work, you don't have to pay back. Therefore, you have to borrow less money, and especially you have a lower cost. You don't have to borrow basically the contingency for the grant, and so you have a lower cost on capital as well because you do not have as much uncertainty. So that's really the essence of it. It's reducing the cost of capital by reducing uncertainty in the financial sense, not necessarily the technical sense. Then you have other type of grants. So for instance, convertible grant that you transform into a loan afterwards. So you might have to pay interest on the money that the risk mitigation scheme provided you. Then, and that's really something that you can introduce when you have already a few projects in your market, but it's public insurance schemes where you have a wide enough portfolio of geothermal projects, enough data on your resources, and then you can propose some form of insurance where developers pay a premium, and then you provide some insurance in case of failure, typically up to 90% of the spent eligible costs basically for drilling. And then that's already what is happening in France. You can move towards public-private partnerships, where some private capital is going to come and participate to this insurance fund. And when you have a mature enough market, then private insurance can be competitive, but you really need to have a deep enough market. Here, I'm going through a little bit of the various requirements for the transition from the various stages. I think I'm running a bit behind, so I might not go into too much details. What I want to insist upon is basically at all stages, consolidation of the regulatory and permitting framework is essential. So you always have to basically have geothermal becoming more stable as an industry before you can transition. So first, you really need to have some form of consolidation of the industry before you can move towards a loan-based de-risking, basically. Then, before you move towards public insurance, you really want to have some form of standardization of licensing procedures and contracts. So you are not necessarily doing things case by case anymore. So you want some depth in your market. Then to move towards public insurance, you really need to have stability in the licensing framework, so no retroactive changes, predictability for the industry, for people to be able to plan their project, mobilize private investment, etc. Have some form of market competition arise between suppliers, and some specialization of suppliers as well. Obviously, better knowledge of your geology, etc. And then things continue to move towards private insurance, and here market liquidity is really essential. So having a wide enough portfolio that it actually can be profitable to insure these projects in case one of them fails, typically, which is the way any insurance markets works typically. Now to invest into geothermal heat projects, we have many different ways to support these investments. So we had feed-in tariffs for heat in the Netherlands, and here it was very interesting because what it led to was a greenhouse operator coming together to directly invest into a new geothermal project and then building district heating from there. So the excess heat, providing it to their communities, etc. So very interesting model where some public support schemes led to actually a lot of private developments, which carry still today the Dutch sector, which is the leading sector, leading country for geothermal district heating, and really build up a very successful industry in 10 years, no more. So extremely successful. Then we have some form of investment aid, which is the way France is doing. So France, in the Paris Basin, you are basically hitting 600,000 people with geothermal. And here, one of the main way to support projects is the Fonds Chaleur, which is providing some form of investment subsidies to projects. And it's managed by ADEME, which produced this study, which I presented a bit earlier. Then we have also an interesting new way to organize the emergence of a market. And here is the case typically in Belgium, which is having some form of public-private partnerships to develop new resources. So in Flanders, so the Flemish-speaking part of Belgium, you have, because in Belgium, energy policy is not centralized. So French-speaking and Flemish-speaking do not have the same energy policies typically. But it's a Johnson & Johnson pharmaceutical company, which is currently developing the Johnson vaccine that we are all hearing about, which is looking to do one of the first non-demonstration projects for deep geothermal in Flanders. And it is doing that in partnership with the public authorities, but it is a private developer that is really looking to do so. And there are several other such examples that are ongoing in the country. Now for private finance, Sanjeev mentioned crowdfunding, very successful, especially as a way to involve local communities, to mitigate or to increase public acceptance, so to mobilize people around ownership of the project. Also for some form of de-risking. That was the case in United Downs in the UK, so in Cornwall, where actually there was quite a lot of, I think, 4 million euros that was mobilized for via crowdfunding to de-risk the project. So as a way to mitigate the risk of an issue during the project development by not having to be exposed to capital cost, basically. Now, green bonds and sustainable finance projects are an emerging tool. They are already used, for instance, for geothermal power plants in Indonesia. We expect they might be more and more important in Europe, as Sanjeev mentioned, the taxonomy on sustainable finance is being developed. So putting some clear criteria for the private sector to invest in renewable technologies. Right now, you don't have clear indicators on what actually is a good area to invest a sustainable finance project in. Now we're going to have these indicators. Geothermal is part of them. So we might have maybe, who knows, some form of renewable pension funds where all the money goes to renewable energy. And here geothermal projects might be benefit, as they have very long lifetime, and once they are actually operational, they are very, very low risk. Corporate sourcing, also very interesting trend. So I mentioned Johnson & Johnson. EGEC in France is interesting, where you had also this model of a joint venture between a developer, a user of geothermal heat, being a factory producing things like cornstarch, etc., and together coming and investing in a high temperature geothermal heat plant. Stock market valuation is an interesting trend as well. We have one notable example being Vulcan Energy, which is basing its stock valuation on the value of lithium contained in geothermal brine, and it's operating right now in Germany. Then obviously loans and equity are always a relevant way to finance geothermal, especially as project finance, but also in some case as corporate finance. So here I have a graph that somewhat summarizes this presentation. Now for Northern Ireland, in terms of how to best finance geothermal energy, we can look at several prospects. I think one very interesting, important thing I will still again insist is having this stable and forward-looking policy and regulatory framework. So we have a lot of examples of retroactive changes or unforeseen changes, etc., which really have a negative impact on the dynamics of the industry. Involvement of local authorities is really a key aspect for the success of projects. We are seeing that throughout Europe. Cities or local communities are really always in the driving seat of especially geothermal heat projects. So it's really important to involve them, and that they do integrated energy planning around their heat decarbonization typically. Yeah, I think I will stop here to leave the time for some discussion.